Hey guys, this is Vulapa, and I just saw this tweet from whatchamacallit asking for people to solve this multiplication page and submitting evidence of them solving it. So I would like to just be more educational about this. I want to solve it ahead of time, but I've decided that maybe solving it in real time blindly is much easier to do. So I will show you how I would do it. So looking at this, we are seeing stuff like tens looking around, and that's the one thing I would like to start with because tens are always easy to do for multiplication. For example, here, 3 times 10, usually you would just add a 0 to the right of the number. So you would get 30. So stuff like this, let's fix this a little so that we can see our answers here. All right. Now let's do that for the rest of the answers here. That's 50. We got here 10, 7, 70. So here 2 times 10 is 20. We got 70 here. We got 8 times 10 here. Let's see, there's 20 here. That's 30 here. That's 5, 0 here. Here that's 90 times 10 is 90. And here 10 times 10, add the 0 is 100. So we go on for everything that we see here. I'm not doing this for speedrun strat, although the original tweet did append a $40 bounty for people doing this in a minute 30, which I could do, but I've decided to just be more educational on this. So now we have all this. So now proceeding further, there's no other tens here in our vicinity. Then we'll just go down. We'll start looking for ones that have a 9 as one of their factors. So right here, we got 3 times 9. What I would usually do is treat the 9 as a tenth initially, which means we add a 0 to this, to the other number. Then we subtract that number by the number itself. So we have 30 minus 3 is 27. And the reason why I would do this is that it's much faster to do tens and then do subtractions in my mind. I think it's just a kink that I do. Anyway, I'm just making sure that answer comes out right. All right, so then we just go through the table, going through the same, explaining this by the way. So if you could do that, then you would go 9, 18, 27, which gives us the correct answer. So we are on something here. Right here, 9 times 7, so which is 70 minus 3 is 63. There you go. So let's go further, 27. And then we got 9 times 9, 90 minus 9, 81. We have something here. By the way, I didn't miss this. So we got the 40 in here. 6, 60, 54. Oops. Want to make sure that your answers are legible, that we're not missing on here. 36. 36. If you're good with your math and you've been just doing this like all the time, then you shouldn't have any trouble doing the multiplication in your head. However, people do have trouble doing multiplication in their mind. And gone are the days where we would actually go through multiplication tables. Nowadays kids are actually just doing this ahead in their head. I mean, it's essential but not imperative to have all these shortcuts, because that way you can just do all these multiplications. Yeah. 45. And there you go. All right. We could proceed further by doing all those and like doing the same thing for the 8s and 7s. But what I would do instead is go for 5s instead. Because those ones are a little easier to consider. 4 times 5 right here, I would do is do the 10s again. So we got 40 in here. Actually, no. Sorry. What I would do is try to split the number here. If it's even, then it's just a easy split. Then you add a 0. Then you would have a 20 on this answer for 4 times 5. So let's look for a better example here while going through the rest of this. 2, split that into 1, and then add a 0. Here we go. Here we go. So now we have a 7 times 5. 7 is an odd number. So trying to split this would give us trouble. So in my mind, I would treat this as the even number before it. The easier way to do that is just subtract 1 from the equation. So this becomes a 6. So now we have a 60 here. But then we add a 5. That's wrong. So we split this number here, 6, into 3. And then we add a 5. So now we have that in our equation. Then we proceed further. We got 30 in here. Let's see. We got 30. We got 40 up here. We got 15 because this minus 2 is 2. Split that into 1, and then you add a 5. We got 35. We got 40 on here. We got 35. We got 25. And that's it. Here on out, you got the 2s, 3s, 4s, which you could do for the 4s. You could do the same way we did the 1s, which is after you do all that. So you treat one of them as 5 here, for example, and then you do all that, and then you subtract the number by itself. However, I do find it much easier to just do the calculation in my head because 4s are just 2's doubled, at least. If you've done exponential stuff, you would understand that. So for example here, 4 times 4 would be 816. There you go. So for here, it's just like a double of it. These small numbers, it's much easier to do like just immediate calculations, especially if you've done counting in your head, just like, adding the number by itself. For example, we got 7 times 3 is just 7, 14, 21, right? Sometimes you would recognize that the simplest answers are just like the easier ones. Here, 6 times 4 and 6, 12. That's double. Then you double that number, it's 24. Anyway, we got 5 times 2 here, which is that's 10. And we proceed further. Right here, 8 times 4, so 816 times 2, 32. If what I'm doing exactly in my head is called refactoring. From 8 times 4 into 8 times 2 times 2, it becomes much easier for the brain to recognize, oh, you can break them into steps to get an easier time. So right here, it would be 7 times 8, which you could do 7 times 4 times 2, which you could break down further into 7 times 2 times 2 times 2. If that's easier in your head, do step calculation, then go for it as long as you don't forget any steps. So right here, 7 times 2, 14, times 2, 28, times 2 is 56. There you go. So let's do that in here. 6 times 3. This one's much easier, but if we would break this down, it would be like 3 times 3 times 2. But then again, we recognize that it's a small number, 6, 12, 18. There you go. If you've done counting, it's much easier to count. But if you're having trouble counting that, then refactoring is probably easier to do. 6, 12, 18. Right here, 7 times 6, 7 times 3 times 2, 7, 14, 21, times 2, 42. Isn't that great, right? So what I've recognized over the years is that people do have issues trying to count upward. So it's not like, they're just failing to recognize just simple addition, but it is troubling for anything higher than 6, for example. It's much harder for us to incorporate things that increment in digits after adding the number by itself. Even 5 is an issue sometimes because we would forget that 5, 10, 15, 20, you would sometimes lose track of that tens digit. So, it's an issue. So sometimes the aim of basic math for students is two ways. Both to make it easier to understand the logic behind math, and 2, to incorporate things that do work for specific people so that they would be able to handle math operations like this. Anyway, let's do a little trick again. 7 times 4 times 2, 7, 14, 21, 28 times 2 is 56. See, I've split it, but also skipped a step because it's much easier for me to just do 7 times 4 in my head. Right here, so we got 7 times 9. 9 can be refactored into 3 times 3. So you can do 7 times 3 times 3, 7, 14, 21. Then times 3 of that is 63. There you go. So proceeding further, 6, 12, 18. 7 times 7 is one of the harder things to imagine. So here, what I would do, actually, is do 2 things. So I would do 3, actually. I would do 7 times 3 first, which is 21. Then I would add the other part of it, which is 7 times 4, which is 28. Then you just add those 2 numbers together, which gets you 49. So this isn't exactly refactoring, but there is a commutative law, I believe, where you can split the product of it into, smaller numbers that represent. If the product can be divided by a specific number, then you can split it as long as one of the factors in it is more than 2. You can split it into 2 smaller numbers that are also factors of that other number. It's a little complicated, so I'm not going to go further on that. In that case, I would say just add them. Just try to figure out what works for you, which in my case is just splitting the numbers. 8 times 8, 64. This is one of the multiplication equations that are just like, square numbers. Once you get into square numbers, these numbers are much easier to calculate in your head. Right here, we missed the 8 times 9, so let's do our stuff again. 8, add a 0, and then subtract a number on it. It becomes 72. There you go. 36, 14, 14. Times 4 is 12. 3 times 5 is 15. 7 times 6. Let's do it again. So 14, 21. Plus itself, 42. 12. Then 6 times 8. 8, 16, 24. Times 2, 48. There you go. 7, 14, 21, 28. Me, specifically, I was born in an era where one of our math classes have us adding stuff by counting upward. Multiplying stuff by adding upward. So I've had the pleasure of going through 6 to 12 and adding upwards from there. 7, 14, 21, 28. We got 21. So that's why I'm doing this counting upward at this point now. So 8, 16, 24. Then add that number to get 48 in here. There you go. 8, 16, 24, 32. So 9 and 32. There you go. 32, if you do 32 plus 16, it would be 48. And 7, 14, 21, 42. And 8, 16, 24. There we go. So this is how I would add all this stuff. Let's just make sure that we didn't miss anything. 27, 42, 4, 5, 20, 3, 10, 30, and 550, 2, 7, 14, 7, 3, 21, 70, 20. Just make sure that numbers are legible. 80, 24, 5, 10, 6, 18, 3, 24, 20, 5 to 10, 7, 9, 63, 32, 70, 15. Oops. There you go. We made a mistake here because I was jumping ahead on thinking of the 5s here. This is why you double check on this. Here you go. That's 8, 30, 39, 27, 99, 81, 318, 8, 7. Here's like the ones that are bigger numbers, so we might want to redo this. 7, 14, 21, 28. That's 7 times 4. They add that number to itself, which is 56. We got correct. 35, 40, 42, 8, 5, 40, 4, 3, 12, 5, 6, 30, 9, 6, 52, 20, 24, 30, 12, 36, 50, 35, 36, 6, 16, 8, 56, 63, 80, and 9, 4, 36, here, 36, 18, 6, 4, 24, 8, 2, 16, 8, 8, 64, 9, 10, 90, 10, 10, 100, 9, 4, 9, 4, 36, 40, 49, 70, 90, 4, 72, 90, 20, 40. Make that eligible. 45, 36, 14, 72, 14, 72, 12, 15, 42, 12, 48, 6, 24, 28, 35, 64, 54, 21, 28, 60, 18, 25, 60, 70, 21, 48, 32, 18, 9, 32, 48, 50, 40, 45, 42, and 24. All right. I hope I hope I've taught someone out there something that could help them go through their multiplication tables. And I hope you enjoyed just listening to this video. Just out of nowhere, figured out I could do this. Well, this is Vulapa signing off. Have a good night.